good morning. Before we start, I want to tell you that the first homework will be put on Canvas today after the class. You have until I believe February 7 to complete the homework and submit it on Canvas under assignments. The homework is supposed to be done in groups of 3. So we have created the groups. So you will also see with your homework this spreadsheet that or PDF file that will tell you which group you belong to. And also there is one more thing that will be giving you, which is a list of IP addresses. That will be, so this will be a list of IP addresses. Each of you will be working on a different IP address. So you have to find your roll number and see which IP address you are working on. Okay, and the homework will be based on the different phases of the kill chain, the Lockheed Martin kill chain. And we'll do another homework. We'll probably in next few days we'll also put up another homework, which will be again due a week later, which is about based on the ATT&CK framework and mapping reports, cyber incident reports to ATT&CK framework. So those are the 2 homeworks that will be due before the midterm exam, and I believe the midterm exam schedule is not out yet, but it will be out soon. It should be around 24, 23 some February or something. So accordingly you have to prepare. All right. So now I had recorded the lecture for last Friday on Thursday, and that lecture I received the lecture only yesterday, so I put it up yesterday afternoon, and I hope that you got a chance to watch it. So I have to ask you a couple of things before we proceed, like so go to menti.com and use this code 14832321 and answer the questions before we start. So at least somebody has watched it. Okay. Give it another minute. So not yet, sir. Close to yes, neck and neck. Those who haven't watched this one, did you watch the previous one? Okay. This class has 91 students, but I am always seeing like less than 50, even less students. So the midterm will be the time when we'll see what happens. Okay, so I see that it's kind of sampling wise, it's kind of half and half. So I would ask you to watch, but now the problem is that the next few questions might be difficult if you haven't watched the video. So let's see, true or false. So whether this statement is correct, hash value as indicator of compromise is not robust, TTP as indicator of compromise is not robust, and IP address as indicator of compromise is not robust. Which ones are correct and which ones are incorrect? Okay, so hash value is basically used for identifying the malware, right? or a document, right? So when we say something as an indicator of compromise, what we mean is that let's say somebody gets attacked, or some company like Symantec or VirusTotal, they come to know of a malware and they tell everybody that, hey, there is a malware going on and this is the hash of that malware. So everybody will then have that check for that hash, right? So they will be always searching for any file that comes with the same hash and then reject that file, right? Now how easy it is for the malware writer. See, when this information is broadcast, the malware authors also will know, right? The miscreants will also know that this hash is now commonly known. So how hard it is for the person to change the hash? He has to just change a bit in the malware file, right? So malware file headers will have a lot of space where you can make a small change without changing anything about the malware, and the hash will change. So as an indicator of compromise, hash values are not that reliable, right? So attacker can change the hash value easily, and therefore if you are just looking for that hash value, you will probably be fooled, right, as a defense. It works sometimes, but it does not necessarily mean that the attacker will sit quiet and let everybody detect him by that hash value. He will change the hash value, right? Now, when the threat intelligence company says, here is a threat actor which uses these TTP, right, these tactics, techniques and procedures. And as a defender, you are detecting what the TTPs, what kind of activities are happening from outside to into your system, what tactics and techniques are being used, and by that you can see whether the one that the threat intelligence company is talking about is actually attacking your system or not, right? Now once that information is known, it is still very difficult, it is difficult for, not impossible, but difficult for the attacker to overnight change its TTP, because it has created, see, you have to hone the skills for attacking a system using a certain techniques and certain type of tactics. So you do not want to give up on all the research that you have done to develop a TTP to attack. So you will eventually change, but you will not change overnight. Therefore, it is rather robust as indicator of compromise. Now IP address, again similar to hash value. If the threat intelligence company tells you, hey, here is an IP address that is being used by threat actors as a command and control or as an originator of a spam, you will block it in your firewall, right? But the attacker can easily change that IP address. They will just change the server from which they are doing the activity, or they will change the DNS resolution from one IP address to the other. So therefore it is not very robust, but it is more robust than hash value. So those of you who have watched the previous lecture, the last pre-recorded lecture, they will recognize this as the pyramid of pain, right? So this is the this is from the pyramid of pain, right? So you go and look for that part of the lecture, pyramid of pain. Now here is an easier question. How many tactics are there in the ATT&CK matrix? Okay, so I would have taken both 12 and 14 as answers. ATT&CK has two pre-attack tactics, reconnaissance and development of payload, and then there are 12 others, like starting from initial access, execution, privilege escalation, persistence, lateral movement, etc. So 14 it is altogether, but usually in the matrix they show 12 from the initial access tactics, but there are two pre-attack tactics, which is reconnaissance and development of the payload. So that's why it's 14. So 14 is correct, 12 is also sort of correct, right? 11 and 13 are probably just random choice, right? I don't see where you got that. So which of the following is not a use of ATT&CK, right? So we have remember we are asking not a usage. Okay, so it's going in the right direction. So in the lecture, pre-recorded lecture, we discussed this different uses of ATT and CK. Of course, authentication is nothing to do with tactics, techniques and procedures. So obviously this is an obvious answer. So when you hear about APT28, so we have mentioned APT28 many times. So I want to know how much you remember. So what do you remember? What comes to your mind when you think about APT28? Okay. So it's like Donald Trump, Russia, right? So it's a Russian threat group, you know, and then you can think about, you know, it's a state-sponsored, government-sponsored. It has been used against the US government, things like that. It's not Chinese or Iranian. So APT28 is a very well-known threat group from Russia. Okay. So last one. What comes to your mind when you hear APT3? Govind? Corona? Korea? Yeah, so APT3 is a Chinese threat group. So most of you seem to know that. Some of you think it's Iranian and some think it is Korean. Now, first of all, you know that there are two Koreas, right? Korea is not a single country. There is South Korea and North Korea, right? And North Korea has very well-known threat groups like Lazarus group or APT37, but this is not one of them. And that doesn't mean South Korea does not have threat groups, or doesn't mean the US doesn't have threat groups, that doesn't mean India does not have threat groups. There are. But usually we talk about, because most of our threat intelligence companies are US based, we normally talk about Chinese threat groups, North Korean threat groups, we talk about Iranian threat groups, we talk about Chinese threat groups and North Korean threat groups and so on. But there are threat groups associated with every government, right? So if you go to the attack.mitre.com org and then you look through the threat groups, you will find Pakistani threat groups, you will find Indian threat groups and so on and so forth, right? So APT28 is also called Fancy Bear, right? So can you imagine what the Indian threat group is named after? Which animal? No? What? No. Well, there may be one, but there is one with the well-known was with elephant. Yeah. Okay, so let's go back to the second part, submodule of ATT-CK. So in the previous classes we talked about what ATT-CK is all about, what are tactics and what are techniques, and tactics and techniques are can be found on the ATT-CK knowledge base, which is very well documented knowledge base at the attack.mitre.org and so on. Now the question is that what is it good for, right? So we said, well, it is good for several things, right? So we said it helps us identify threats or threat groups. It helps us compare two threat groups. It helps us to emulate adversary, to see what an adversary does by going through the various tactics and so on. And then in general it helps us to understand what an attack is, how it gives you a frame of mind through which you look at, it's a lens through which you look at an attack. So an attack does not happen like, just you send a phishing email and you get your computer gets compromised and that's it. It's not like that, right? So threat groups want to do a lot more. Once they compromise your computer, they want to create persistence, they want to create lateral movements, they will move to other machines, they will try to do data collection, they will try to do data exfiltration, they will try to do credential access, all kinds of stuff, right? So it gives you a handle on how to describe an attack. So most attacks can be described as, as a sort of like a sequence of tactics, and then also identify which techniques were used to implement that tactic, right? So now what happens is that when these companies like Recorded Future, FireEye or Mandiant, Microsoft, Google, Security Labs, they all have sensors all around the world, right? So they collect data from various locations like traffic, internet traffic and so on. And from that, they try to figure out what is happening. So not only it tries to understand an attack that has been already reported, and maybe a Mandiant has been called in to do post-mortem analysis and so on, but they also do observe the internet for various types of traffics and activities, the malwares that are discovered and all that, and they try to make sense of it, and they create these threat reports. So these threat reports are often then published as part of their I would say free service to the community. So you will find that Recorded Future publishes threat reports, the Mandiant publishes threat reports, Microsoft publishes threat reports, and so on and so forth. So these threat reports have all the description, like this is how the initial access happened. It came through a Log4j vulnerability, or it came through a spear phishing and things like that. Then they will say that, okay, the malware, the first payload that came in, that exploited so and so vulnerability to do a privilege escalation. Then they will say that after the privilege escalation, they actually went for the file that contains the hashes of passwords, and then they actually send it to their command and control server at so and so IP address, where it was this hash file was they tried to do a dictionary attack or rainbow attack on these hashes, discovered some credentials, then they use those credentials to get into the system and things like that. So they will give a very elaborate description of what all happened, right? Now once you have that, as a defender, what good is it, right? So I subscribe to a number of different cybersecurity news sources, and every day I get to read like 5, 6, 7, 8 such threat reports, right? So what do I do with that information? Okay, so I can talk about it to others, that hey, do you know that this happened or that happened, and it may give me an idea that, oh, this also can happen, things like that, or it can give me an idea that this particular vulnerability is there in the Windows Office, so I better think about patching it, and things, this kind of knowledge I can get. But as a defender, I have to get more out of this, right? So to get more out of this, I have to basically figure out how can I use this information to actually defend my infrastructure, right? So there could be many ways to do it. One is you take bits and pieces of indicators that are in that report, like there are some IP addresses in that report. So I collect those IP addresses and I tell my firewall guy that make sure that these are blocked, right? I see that certain versions of Windows are exploited. So I tell my system administrator or asset manager that make sure that none of our machines have that version of Windows, it should be patched immediately. So I can use bits and pieces of that information or indicators for doing some security, but that's not very systematic, right? So what is the way to do systematic utilization of such reports, right? So you have to extract this information in such a way so that you can actually use this as designing your defense in a systematic way, or checking your defense in a systematic way to see whether your current defense will be able to stop or detect if these things happen in your system. And also there is a threat intelligence exchange format called sticks. So sometimes I can actually put it into this sticks format. It's actually kind of like a meta programming language in which I can put all this information. And then many of the modern tools like firewalls and intrusion detection systems and endpoint detection systems, they actually understand sticks. So if you give a new sticks file to them, they will make sure that those indicators are actually used for blacklisting or whitelisting or whatever they want to do. So therefore, what we want to learn in this submodule is how to take a report, finished report, what you call finished report, a report that has been published about a threat activity by a well-known threat intelligence company, and how to map it to ATT and CK, right? So that is the first thing we want to do, right? So again, to remind you that we started with what is ATT and CK. Now we are going to learn how to use the finished cyber incident report to map to ATT and CK. Then we'll see that how to map raw data, that sometimes there is no finished report of an incident. It may have happened to your organization, so you have indicated various kinds of raw evidences that this happened, like some logs and some malware samples that you collected. There may be some extra files created inside your system. You found that some IP addresses were contacted which you don't recognize. So you use those information and map to ATT and CK. So that's harder, but that is what you most probably will do. Most of the time you will not get a completely finished report. So that we'll do in the next module, next submodule. Then we'll show you the tool that MITRE designed called ATT and CK Navigator, and then we'll see how the defense recommendations are done based on the mapping that we have created. So the basic idea is that cyber threat intelligence, right? So to defend your organization cyber infrastructure, you need to know many things, right? So who is attacking us, right? Not every kind of organization is attacked by every threat group, right? So there are certain threat groups focused on certain sectors, certain geopolitical region, and so on and so forth, right? So who might be attacking you and what their motivations are, which will give you an idea about what they might be actually after, like is it data, or is it to extract money from you through ransomware, or is it just to create disturbance or denial of service. So you have to know what they might be wanting. Then you have to understand what is the frequency and volume of the attack, what are the attack surfaces that they actually exploit, right? Is it like internet facing services that they are exploiting, or is it are they doing a supply chain compromise, or are they stealing credentials of legitimate users and get into your system? What surface they are attaching themselves to do the first access? And then you have to understand the tactics they are using, and then what techniques they are using to implement the tactics, then what procedures they are following to actually implement those tactics, then what kind of malware they are using, what is their command and control infrastructure, and then any other indicator of compromise like hashes and other artifacts, URLs, files, digital certificates, all these things. So if you have all this information, it's easier for you to actually defend against at least that adversary. Doesn't mean you are going to defend against other adversary, but for any adversary, if you have so much information, then you can do better with against that adversary for sure. ATT and CK and threat intelligence. So ATT and CK actually is about adversary's behavior, right? So tactics is a sequence of tactics is basically their behavior unfolding, right? This is what they do first and second and third and so on. So structuring the threat intelligence, you can structure threat intelligence in many different ways. You can give it as a text, you can give it in the form of sticks file, you can give it in terms of TTPs. So what it is saying is that structuring the CTI with respect to these tactics, techniques and procedure will allow you to do compare different threat groups, check your defenses, which groups, what defense works against which groups and so on. And the other thing is that when you are talking to a fellow security professional, if you try to describe something in natural language that this is what this threat actor does, it may be interpreted differently by different the security professionals. But if you use the common language, common vocabulary in terms of tactics and techniques, then there is no space for ambiguity. So for example, let's say APT18, it uses, it steals credentials maybe from various places, and then they log into external remote services. So if you have a remote login into some system, they somehow compromise your credentials, and then they use that and pretend to be you, impersonate you. APT29 also uses compromised identities to access networks through VPN and Citrix, and APT41 also compromised billing or payment services using VPN access between third party and the main targeted payment service. So in all these cases, you can describe all this, but one thing that a person, the security professionals who are familiar with ATT-CK, if you say that they are all using T1133, that is using remote external remote service to penetrate your system, to making the initial access, they will all understand the same thing. So that basically is saying that the use of a common vocabulary, you can define your own vocabulary, but that vocabulary may not be known to your colleague or another security expert in the same sector with whom you are exchanging information. But if you do this in terms of vocabulary that is common, then you can actually make more sense to each other, and that will be useful and helpful to each other. So mapping from finished report to ATT and CK. So as I said, that lot of people think of threat intelligence as just indicators of compromise, right? So now indicators of compromise can be many types, like hashes are indicators of compromise, IP addresses are indicators of compromise, malware samples are indicators of compromise, URLs are indicators of compromise, certificates can be indicators of compromise. So what is an indicator of compromise? So if there is a compromise in one place and you collect various artifacts from that place and make it known to everybody that if you see this hash and if you see a file with this hash, if you see the malware fragment like this, or if you see communication going to this URL, or if you're going to see communication going to this IP address, then you know that you are also compromised by the same threat actor, right? So that's why it's called, these things are called, these digital artifacts are called indicators of compromise. Now indicators of compromise, when you give it in terms of digital artifacts, if you have seen the pyramid of pain, you will see that most of it for the attacker to change these indicators is not that difficult, right? But if you share the threat intelligence in terms of TTPs, then as I said that the TTPs are more difficult to change overnight, because it requires a lot of time and investment to actually come up with the techniques and tactics that will work on a particular target. Now you cannot overnight change that TTP without investing more time and money into it. So therefore this TTP based sharing of intelligence is good. Now sticks, as I said, is a format by which you can share threat intelligence, and nowadays it is being done more and more, because even our CERT-IN, Indian Computer Emergency Response Team, or our NCIPC, they also share threat intelligence in sticks format. So if you have the right tool, like your firewall, etc., can actually ingest sticks format and automatically configure itself to stop those indicators, that's good. That's what is being used more and more. So sticks is something we'll be discussing a lot more later in the class. But all these things, notwithstanding all these things, we can still use ATT-CK mapping of threat incidents and use that to disseminate the information to others who also can then use it for making sure that they are protected against these techniques and tactics, right? So there are 14 tactics as we saw, and then there are more than 300 techniques, and the techniques database keeps increasing, right? So now the question is that how do you go about doing this? So how do you map the incident report to ATT-CK tactics and techniques? So first of all, you have to read the report and figure out what all things that adversary did, what he did first and what he did next, what he did after that, and so on. And then you get the idea about the behavior of the adversary, what the adversary was doing. Now some of the behaviors you may not immediately know that, oh, this is this tactic they are using, right? So in the beginning, once you become very experienced with this, you will immediately say, oh, this is this tactic and this is this technique, right? But it will take some time to get to that level. So you have to do some research, right? So you have to go to the ATT-CK website and do a search, like you say some behavior, you do the search, it will give you all kinds of tactics and techniques that might be relevant to that behavior. So you have to then figure out which one is a good fit. Then you have to translate the behavior into one or more tactics, and then figure out which techniques have been applied to achieve that tactic. And then once you have done that, once you have completed the whole mapping, you then ask another analyst to do the same and then compare, because everybody has a different understanding of these things. This is not exactly science, this is more like expertise based kind of mapping. Now this mapping, as I said, can be from the finished report or from raw data. Now in this sub-module we are talking about finished reports, so we'll focus on finished reports. So to understand the behavior of the adversary, first thing you do is that you focus on the verbs, right? So the verbs will tell you what the adversary is doing, right? So what did the adversary do on the system once it is compromised, right? Or how did it get the initial access, or how did it find the vulnerability that it exploited? How did it create the persistence, or how did it do the privilege escalation? How did it become the root user basically? Whether it exfiltrated data, or whether it changed any settings, or whether it used malware, what kind of information it looked for or exfiltrated. This kind of stuff you have to ask yourself while reading the report. So here is a fragment of a report, and this report is actually in this, here is a hyperlink. When you get the slides, you will find this hyperlink, so you will find this report from Mandiant. And this is just to show you an example about how do we go about finding the behavior of the adversary. So here you see that here that particular CVE was exploited. It's a kernel vulnerability, and if you exploit this, it will give you the root access. So you can see that in this is middle part of this report, right? So you are not going from the beginning. This is just to show you how you actually go about doing this. So you will say, okay, so it is exploiting a particular vulnerability and it is getting root access. Now then it says that there is a malware component which uses certain command.exe with a particular command who am I, to figure out whether it is running as root or not, right? So who am I will tell you whether it's root or not, and if it finds that this is system, then it creates a task, a scheduled task. So it's a scheduled task is being created, right? And this scheduled task will run this test.exe malware, right? So this is what is happening with the persistence, creating persistence. So here we saw privilege escalation, how it did privilege escalation. Here we see how it created persistence. Now you see that then it says when this malware is executed, it first establishes a SOC 5 connection to a particular IP address outside using the TCP port 1913, and then it gives a connection request with a specific code and make sure that the server responds with a specific code. It is basically a kind of a handshake, right? So what this is trying to do, this malware is trying to establish its connection with command and control, right? So in this little fragment of this report, we are finding a privilege escalation, we are finding a persistence, and we are finding a command and control. So 3 tactics are easily visible. There may be more, but these are very easily visible. Now, so this is where you actually are finding the behavior, right? So we are just showing you one snippet here. Then now if you do not know what this behavior, so let's say you see that that it is connecting using SOC 5 to an unknown IP address, and you do not know that that is the command and control tactic, then you have to do research, right? So you have to go to the attack database and search for this behavior, and it will probably give you a number of choices, and then you will have to pick which one is the right behavior, right tactic describing that behavior. So you can also do external searches like what is SOCS. SOCS is basically is a proxy server. So if any of you have used any kind of a web proxy, like for example Burp Suite. Burp Suite is a tool for creating a web proxy so that all web traffic from your browser goes to the proxy, and that's where it gets external entities only can see the proxy, not your browser. So all the encryption SSL TLS terminates at the proxy, and therefore you can see the traffic between the proxy and your browser in plain text, right? So that's how we actually do debugging of web applications and so on, right? So SOC 5 is the protocol that is used for that kind of proxying. See, the different malware uses different protocols for connecting to the command and control, right? Some may use HTTP protocols, some may use some even DNS protocol, and some could use application level protocols, right? So in this case, this is using a SOC 5 protocol, and it is using a rather non-standard port 1913. So you might actually look for details. So here is a website called SG Security, where you can actually find about all the ports that are normally what services use those ports, right? Now remember that port number 121024 are standards, right? So standard ports. Those ports are used for specific services, most of them. But 1913 is outside that range, so it is actually rather custom port, right? So this whoever wrote that test.exe malware, they decided to use this port, right? Now if this malware was inside IIT Kanpur in your machine, on the IITK network, will this work? 1913 port, is it open or closed? Actually it doesn't matter, because unless explicitly our firewall stops this port, outgoing things will always go, right? Anyway, so now you have to translate the behavior into tactics. So the good thing about translating behavior to tactic is that you have only 14 choices, right? You cannot go very wrong, very far. Like nobody will say, well, initial access, confuse initial access with let's say privilege escalation. It's not easy to make such confusion. So tactic finding is not that difficult. So here For example, this one, this is basically a snippet from the one that we showed before, and here you see that this can easily be attributed to command and control tactic, right? So this was easy. The harder part comes when how to find the techniques, because there are 300 plus techniques, right? The good thing is that not all techniques relate to all tactics, right? Every tactic has a set of techniques. Some techniques actually are common between multiple tactics, but few of them. So if you know what tactic you have identified, then finding the technique would be not searching for the all 300, but the subset that applies to that particular tactic. So you have to look at the techniques identified in the attack matrix for identified tactics. So if you have done the tactics correctly, then you have narrowed your possibilities, and then you do this website search and all that stuff, and some behaviors may not have an existing technique, right? So in that case, you actually may report a particular new technique that you have discovered to attack.mitre.org, and your name will eventually, if they accept that, your name will be showing up in that page, right? So who contributed to that technique. So in this case, you have command and control, and then there are two techniques that seem to be working here, that is custom command and control protocol. They are using a custom command and control protocol, and then they are using a well, not a commonly used port, but it is rather uncommonly used port, right? 1913. So it's a standard non-application layer protocol, so that is T1075. So when you say SOX 5 connection, it's not a non-standard protocol, it's a well-known protocol, right? But it is not at the application layer. Many times we design an application layer protocol which eventually uses the lower level like TCP, IP, etc. But we look at, then in that case we will say a custom protocol, but this is a standard non-application layer protocol, and it is also uses a connection proxy, so that is T1090. And this is there are two alternatives: commonly used port or non-commonly used port, uncommonly used port. So here T1065 will be the more appropriate, because this is not a commonly used port, right? Port knocking is not at all the thing here, right? So when you search on port on the attack website, it gave you a number of techniques, some of which are totally absurdly unrelated, like port knocking in this case is not related, right? But you have to know that, right? So otherwise you will be confused. So you then go and repeat this procedure. So you basically do this process again and again on all the verbs. So here you will see that after you finish, you will recognize privilege escalation, exploitation of privilege, exploitation for privilege escalation was the technique. Also it executed, so therefore it's a command.exe, so it's a command line interface. It also does discovery by doing who am I, so there is a system owner user discovery technique. It also creates persistence by scheduled task, so scheduled task is the technique. So command and control was used here, and with a standard non-application layer protocol and uncommonly used port. So after this, only this 6 lines, you find 3 tactics and at least 6-7 different techniques being used, right? So this is how you have done it. Now we don't have time to do this exercise in class, so I'll ask you to do this and we'll ask you about it tomorrow. There is a particular Finnish report by Cyber Reason called Cobalt Kitty report. There are 2 PDF files here. One already highlights the verbs, and the other actually and has tactic hints. So one version of the PDF has tactic hints which can help you, and the other one is highlights only, which highlights the verbs. You have to know the tactics. But you also have find the techniques for each of these, right? And once you have done that, you actually can compare the results with your friends, and we'll discuss this in the next class and see how you do it. Okay? And this will be similar problem will be your second homework, so you better try to do it, right? Okay.